usually abbreviated EV. Okay, so that's center. What's the third thing we want to get? Shape, center, think. Yeah. So that's called spread. We're calling that spread. So we're going to use a standard deviation. And that standard deviation is going to be abbreviated with a sigma, lowercase sigma. And, pardon me? Yes, the summation sign is an uppercase sigma, as is the sign for the integral is also an uppercase sigma. Yes. Yeah, that S looking thing is also called a sigma. Yeah. It's kind of like one of them's handwriting and one of them's printing. Yeah. All right. Isn't that interesting? Okay. So yes. I'm not that up on the SATs to know if they asked. Mr. Jacobs would know, but it is supposed to be something that's supposed to be learned in high school. So, yeah. Oh, I'm sorry. The SAT the SAT did have standard deviation on it. Oh, good. It is a high school topic. So, did you get it? Good. Cool. All right. Alright. It's going to be one of those days you're never going to get through everything. We have to have rallies, don't we? All right, so we're going to find, in getting our standard deviation, we're going to get the variance, and the variance is abbreviated sigma squared, because if I get the variance, if I just square root that, I get the standard deviation. So, yeah. So, because we have a random variable, our calculations are going to be just a little bit different. There we go. So, my formula for for variance, I'll do variance first, is going to be kind of like the formula we did before. I still got a summation. I take every value that my random variable can take on. I subtract the mean of my random variable. I square it, and then I multiply it by the probability of that random variable. Then I add all those up, and I don't divide. Kind of my division has been taken care of by the probabilities, because they add up to 1. Okay? So in the example we had, you could have 0 cars. What was our mean? Oh, 1.75. Square that. Multiply that by 0.09. Add to that, you could have 1 car. And that was 36. And you could have 2 cars. And that was 35. You could have 3 cars. And that one was 13, sorry. And 4 cars. And that one was 5. And 5 cars. And if you had any more than 5 cars, you're just being a little excessive, I think. So, yep. Right. Yep. Yep. The probabilities are weighting it. All right. I need a calculation for the variance. I can wait. I notice some of you waiting with your hands in your laps, and some of you can punch buttons in a calculator. .03 for the variance. Nope. Doing badly so far, unless I've written something down wrong here. Oh. 1.1675? Okay. That's the variance. I don't want the variance, although I use it as an interim calculation. What number do I want? The standard deviation. So that's the square root of 1.1675, which is 1.0805. Huh? Oh, is that the problem? Maybe that's the problem. I forgot to square it there. Okay. All right, let me give you one and let's see if you can do this and get this one right. I'm going to have a new random variable. My random variable y is going to be the number of motorcycles. And I'm going to keep this one small, so I'm going to say you can either have 0 motorcycles, 1 motorcycle, 2 motorcycles. If you got more than 2, that's just way too much noise. Yes, noise pollution. Okay. Shh. It's okay when you those people that ride those noisy motorcycles. Most of them die anyway in the motorcycle accidents. So. Oh. Roy does? Get off that thing! You're gonna die. God. Okay. This is a simple one. See, this only got 3 terms. Can you find? Shh. Can you find your mean and your standard deviation? Mean is 0.19, so the average number of motorcycles per household is about 0.2 motorcycles. Standard deviation. If you'll do the calculation, I'll show you. I'll show you the shortcut. What are we getting so far? 0.44, Daniel, good. That was it. All right. Now, for those of you who are a few seconds behind, it's okay. Hit your stat key. Not your stats key, your stat key. Oh, thanks. Standard deviation. Okay. Go into your list. In one of your lists, put the values your random variable can take on, and in the other list, put the probabilities.